orbiting under gravity. Thanks for watching this video and don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. Before you work through this video, you will need to know how to find the gravitational field on the Earth's surface. If necessary, you should refer to the following video, which covers this topic. We have already seen that the gravitational field around a spherical object, like the Earth, is given by the formula. And of course, the value of g will change as an object is moved further from Earth's center, since at a height of h above the surface of the Earth, the field strength g is given as follows. Let's see how it works. Determine the acceleration of the Moon about the Earth. Write down the expression for the gravitational field strength and substitute the values given to get the acceleration. Newton's first law of motion states that a body will continue in a state of rest or uniform motion in a straight line unless acted upon by an external force. Any object moving in a circle must therefore be acted upon by a resultant force in order to produce the required acceleration towards the center. A force towards the center is called a centripetal force. A resultant centripetal force is necessary for a particle to move in a circular path. For an object orbiting another object, such as the Moon orbiting the Earth, or a planet orbiting the Sun, gravity provides the centripetal force which keeps them in orbit. Therefore, the acceleration of gravity is the centripetal acceleration. If we equate them, we get this equation. This equation allows us to calculate, for example, the speed at which a satellite must travel to stay in a particular orbit. The equation above can be applied to the planets of our solar system. Determine the orbital speed of the Moon as it orbits about the Earth. Take the values given in the previous example and substitute into the equation. Determine the orbital period of the Moon. To find the period, we take the formula to calculate the linear velocity in a circular motion and solve for period. Determine the centripetal acceleration of the International Space Station. Take the equation and substitute the values given in the previous examples. You should notice that there is no zero gravity in an astronaut's orbit. The term just means that the astronaut is in free fall, accelerating with the acceleration due to gravity. Determine the orbital speed of the International Space Station. Take the equation and substitute the values given in the previous example. Geostationary satellites are satellites which are orbiting the Earth above the equator and make one complete orbit every 24 hours. Because their orbital period is synchronized with the Earth's rotational period, a geostationary satellite can always be found in the same position in the sky relative to an observer on Earth. Determine the orbital radius of a geostationary satellite. We have to combine these two equations to get the orbital radius of a geostationary satellite. Let's solve for distance. This is the distance the satellite needs to be from the center of the Earth. Subtracting the Earth radius, we get